Hello, welcome to the software-defined radio MOOC. On this module, we are going to describe the transmitter and receiver blocks of a radio software device. A radio software transceiver, an heterodyne receiver, a direct conversion receiver, and a low IF receiver are different types of receivers used in software-defined radio hardware. We are going to describe first a general block, and then we'll describe different configurations. This is the general configuration of a software-defined radio board. The board has first a bandpass filter to select the desired frequency band, and then it has an RF front end, which is composed of an receiver and transmitter part. The receiver is composed of a low noise amplifier, we call it LNA, a mixer, and analog to digital converter. The transmitter is composed of a digital to analog converter, again a mixer, and a power amplifier. To switch from transmission to reception, there can be a switch in the output connecting the antenna to the RF front end. This front end takes the signal to a digital signal processor, which usually is the PC. There are different configurations or receivers. One of them is the super heterodyne receiver. Super heterodyne receiver has a lot of analog parts. It's composed of a bandpass filter, low noise amplifier, intermediate bandpass filter, and low pass filter. This is the classical architecture of the traditional receivers, and normally it has two local oscillators, one for the RF and one for the intermediate frequency, and several filters. The most important is the bandpass filter located in the middle of the receiver, and this filter selects the bandwidth that the system is able to handle. The radio frequency filter is very important to select the frequency band and to reduce the interference and the effect of the image frequency. The disadvantage of this module is that it has a lot of analog components, therefore is complex to control and expensive, and take a lot of space because of the analog circuits. Another type of receiver widely used in radio software device is the direct conversion receiver. This receiver has very few analog parts. There is only one bandpass filter, the low noise amplifier, the mixer, local oscillator, and low pass filter. And then the input goes to an analog to digital converter. This circuit can be highly integrated, but has the disadvantage of the low image rejection because there is no intermediate frequency filter, and there is a DC offset generated by the cell mixing of the local oscillator. This is very uncomfortable because usually we have a lot of power in the zero earth frequency components, which reduce the sensitivity of the receiver. An intermediate solution is the low IF receiver. This is the best solution for software-defined radio device, and it's also used by the RTL. Here the analog parts are very low, very reduced to a bandpass filter, low noise amplifier, and there is a bandpass IF filter. This filter helps to reduce the interference and the image frequency. It doesn't have any problem with the DC offsets, and on the other hand, it has the disadvantage that the AD converter must be very fast because normally the IF is higher than the baseband frequency of the 0 IF receiver. So here we need a better performance AD converter. Really, this receiver behaves like a super heterodyne receiver because it has the second frequency conversion made in a digital demodulation unit. This unit is included in the device and makes the same things as the analog circuit in the heterodyne receiver, but digitally, so it can be integrated in a digital signal processor. Now we are going to make a short review of the components of a RF transceiver. The components I have mentioned before are amplifiers, mixers, filters, oscillator, AD converter and DA converter, and finally the modulators and modulators. These are all the blocks we will need in a radio communication transceiver. Amplifiers. This is the first part. We can define two types of amplifiers. One will be the receiver amplifier, and this receiver amplifier has three main parameters: gain and noise factor and input-output impedance. For the receiver, the principal parameter is the noise factor. This amplifier must have a low noise to increase the sensitivity of the receiver. In the other hand, in the transmitter part, we have output power amplifier. This amplifier must give a medium or high power output to get a good transmitter. In both amplifiers and for software-defined radio, it's very important the intermodulation. This intermodulation is a nonlinear behavior of the amplifier which degrades the receive or transmit signal, and it generates an undesired frequency spectrum. So it's important to have a low intermodulation device both in the receiver and in the transmitter. Here we have the general schematic of an amplifier with the input impedance, output impedance, and the power gain definition. The second block is the mixer. The mixer is very important because it has to make the frequency conversion from the receiver or from the transmitter. The mixer in the receiver multiply the local oscillator frequency with the received frequency to obtain an intermediate frequency. In the transmitter, it makes a multiply of the local oscillation signal by the IF to get an output RF. In the process, we generate other signals. Some of them are the local oscillator and some non-desired components like the image frequency. We can see these signals in this frequency spectrum. If we see a receiver, we get the RF as desired as received signal. We have the frequency of the local oscillator, and the output will be the intermediate frequency. With these three signals, we have also an image frequency that can introduce some degradation in the reception process. In all cases, the bandwidth of the RF and intermediate frequency must be fitted to the modulation of the received signal. Another important point are the analog filters. We require a bandpass filter in the receiver or transmitter, and we also need low-pass filters behind the AD converters or the DA converters. The most important parameter of the filters is the order. The order of a filter gives a better response when the order is high. Here we have a graph where we can see a low-pass filter from order 1 to order 5. We can see the slope of attenuation of the order 5 filter is much better than the slope of attenuation of the order 1. These filters are important to reject image frequency and to select the IF frequency bandwidth, which is very important for the quality of the modulation and the modulation process. Then also we have another important part, which is the most important analog part of the SDR, and this is the oscillator. The oscillator can be fixed or variable, and they must select the receive or transmit frequency. Normally SDR use wideband oscillator covering several hundreds of megahertz. On this oscillator, the quality is measured with the stability. We can say that stability is measured in parts per million. If we have a stability of 10 parts per million, this is bad stability. A lower 1 part per million is very good or good stability. Normal device has a range in 110 parts per million stability of the oscillators of the device. There is also another important parameter, which is the phase noise. We call short time stability to the phase noise. This is important, especially in digital modulation, because can generate errors in the receiver or in the transmitter. So we can say that stability of oscillator is the main parameter for a quality software-defined radio. Finally, we have the AD and DA converters. These converters has also a very important task in the software-defined radio device. The DA traditionally are much better than the AD converters, so the key part is the AD converters. On these converters we have the resolution, or the number of bits, which is the principal parameter. If we have more bits, we get less noise in the analog to digital conversion process. Normal device of SDR has from 8 to 12 bits. RTL SDR use 8-bit converters, and high quality SDR device use 12 and even 14 bits converters. Another important quality factor of the AD and DA converters is the spurious-free dynamic range. The converters can generate spurious, and it's important that this spurious maintain low during all the AD and DA converters. So really the price of the SDR device, it depends a lot of the AD converters used in the receiver. Modulation and demodulation. This is the most important part for the software-defined radio. Really, the software-defined radio is developed to handle different types of modulation without using different types of modulators and demodulators. In the past, if we have analog or digital modulation, we need a different modulator or demodulator for each technology. AM, FM for analog, or AS key, FS key, any of them need a different modulator or demodulator. Now this hardware modulator can be replaced by a software-defined radio system where the modulator is implemented as a software modulator or demodulator. That's it. Thank you for your attention. You can follow us on Twitter or Google.